Hi, we're going to implement a simple Caesar cipher for uppercase characters and spaces. So the idea is that we have the uppercase alphabet as a built-in. We just need to also have a space in front, and we can make a lambda around this where we take the argument, which is represented by an omega, which is the rightmost characters in the Greek alphabet, and we take a message and we can look it up with the index of here. So we look up every character in the alphabet. So we can see H, which is normally the 8th character, but it's now the 9th because we have a space in front. And then as left argument, we take a rotation of the alphabet. So we can take the same alphabet over here. And then we can index into it, and then APL allows us to index with multiple values at once. So we take all these indices here, and we use them to index into the alphabet. Of course, if we index into the alphabet itself, we get the same thing. But if we take alpha, the leftmost character of the Greek alphabet, and we rotate the elements of the alphabet, we can also show how that looks. So if we take this, oops. So this is a rotated alphabet. Then that's a solution to that. Let's clean up the code a little bit. We can see here that we have some duplication of code. We can do an inline assignment over here to A for the alphabet, and then we can use the A over here. And we can avoid this parenthesis by flipping the arguments of the iota of the index of function. So let's do that as well. Reads nicer with the inline assignment as well. And there you have it. Let's give this a name. And apply it. Oop, of course, we need a left argument there to apply it. There we go. And then, of course, once we have that function, we can apply it in reverse. And if we apply the reverse on the forward, then we get back our original message. So same function works for both encoding and decoding. And the way that works is that we have a negative value on the rotation. It just means reverse rotation. So that's all. Thank you for watching.